Good morning, everybody. I hope everybody's doing well today. Glad we got about 4 or 5 people online. That's really good. Good morning, everybody. I hope everybody's got the doing echo. Well. Turn the echo off. All right, so take a look. How's everybody doing? Got my Superman outfit on. You doing okay? We're working on, remember, what we're doing is we're reviewing for the test. The test will be next week. This is Unit 5. Okay, so we started, let's switch over here. We started on the difference between linear, quadratic, and exponential. Okay, that's what we did. So if you're stuck on that, if you're unsure about that one, you could look at the last video, and we did the first 2 pages on the last video. So just review, just a little review here. Linear, the change is adding or subtracting, if we go the other way. The change is adding or subtracting, depending on which way we go. So that's linear. See how it goes up by 5 every time. Quadratic, remember we had a little pattern here. Odd numbers, 1, 3, 5, 7. That was our pattern for quadratic. Also, remember quadratic makes the U. So if I have a point that's 10, like 3, 10, there's another point on the other side at 10 also. That's another way you could recognize quadratics. Exponential, we don't go up by adding, up and down by multiplying. This is times 2, times 2, times 2. You see that? You see how it changes by 2 every time? That's exponential. That's what we're working on. And that's what this unit's about. This unit's about exponential. So here's the first, here's yesterday's work, and let's just do a practice of exponential. This is what we did yesterday. Okay, so look what we did. Fill out the table. We start, $1,000 is placed in an account. Earns 5% annually. Now remember, if the equation, remember what the equation is. Okay, got to find my calculator. Hold on, I thought I had it right here. Lost my calculator. Say hi. Oh, sorry. Left my calculator back there. All right, the equation is, if it earns 5%, then what we do is we take 1,000 and we multiply it by 5%. Now remember, percent, you got to move the decimal place over. So we earned $50. But we don't have $50. We got to add that back to the original amount. So really, the amount we have is the $1,000 plus the $50. Okay, so obviously we do a little better way to take that. The best way, we had a nice little formula. The amount is your starting value. They call it P. And then we had an exponent here. Remember our formula from yesterday, we talked about it. This is the y-intercept, and then this is the change. Okay, it had A and B on the calculator. Oop, I put that in the wrong spot, sorry. Put that in the wrong spot. Okay, so what goes in here? Now, if it's, we had 2 different formulas. If it's growth, 1 plus, that's what this is. This is growth. If it's decay, 1 minus. But this is the most important thing in a word problem. That's the percentage change. That's how things change. So, for example, this one, the amount is 1,000. That's the y-intercept. 1.05, notice bigger than 1, so that's growth to the t. There's our formula. So, for example, if I wanted 2, I take 1,000 times 1.05 to the, remember your 2 the buttons above your divide, 2 years. And it looks like 1102.5. It's money, so we'll go 50 cents. Everybody see that? And if I want 3, just watch this little trick, second enter, get you back up here, and you can type a 3 in there, and then it's 1157.625. And then we go second enter, and we can go back there and type a 4 in there. You could do that on any TI calculator. 1215.5. I'll round for money. You see what I mean? All you have to do is plug in whatever one you want to plug inside there to see how it's growing. Now notice this is not linear. This went up by 50. This went up by $52.50. Okay, that went up by $55.12. You see how that's not the same? It's a multiple. We multiply it every time. Okay, oh, I wrote the function here. So A of t is 1,000 times 1.05, since it's growth, that's bigger than 1, to the t. That's what we said. Does that make sense? Okay, here's where you speak up in the chat if you know you're confused. When is it double? Well, if we have 1,000, what's doubling? 2,000. So 2,000 is what we want. Okay, now how are we going to solve something like this? That's a tough solve. So the easiest thing to do is on your calculator, go to your graph. Clear out the old stuff. Type in 2,000 for the left side. Type in 1,000 times 1.05 to the x. Now remember, don't just hit graph right away, just hit our window. Remember, the numbers are in the thousands. So we'll go from 0, I don't know how long it's going to take to double, so we'll try 10 years. And we're going from 0 to the y. Well, doubling is 2,000, so I'll be safe and go to 2,500. Remember, the x's are the years, that's the independent variable, and the y's are the money. So let's see what happens. There's the horizontal line, there's 2,000. Here comes the exponential growth. And, more than 10 years. So you go back to your window, and let's make it 20. Let's see what happens. Horizontal line, and let's see what we got. There's the intersection. That seems like the easiest. Second calc, find the intersection. Remember, we did this hundreds of times. And it looks like about 14.2 years when t is 14.2 years. Now remember, years from, what's the starting year? From 2013. Don't forget about that. We're starting at 2013. So what does this mean? Let's see if we add 14 years to that, 2027, we will have $2,000. It takes 14 years to double our money at this interest rate. That's what we're talking about there. All right? There's a good problem with doubling. You see how sometimes we have to plug in the number here. Remember what we're plugging in. We're plugging in time into here, but money into here for this equation. How's that? All right, let's do another problem. Do another example. All right, take a look at this one. Okay, houses have depreciated. Depreciated. Now, remember, if you're ever stuck on a word, you can always look it up. You got the internet in front of you. Depreciated means going down. So whereas the before, remember this one, the money is increasing, so it's 1 plus, while this is decreasing, so it's 1 minus. So, for example, we have the amount is the starting value 1 minus to the t. Remember our formula. It's either 1 plus or 1 minus. And it's still following, let me change colors here. It's still following our form, y equals ab to the x. B is what's inside the parentheses. A is this thing right there. And there's x is t in this problem. You see, it's still formula, just like y equals mx plus b. How can you tell from the words that you're using an exponential function? Because of percents. Percent per year, not amount per year, but percent per year. That's the key. Exponentials go up and down by multiplying. And remember how when we multiply by percents. Okay? So let's see what we got. We're starting with the home was purchased. So 2005 is year 0. And how much do we have? The money is, let's put the money on this side, is $100,000. How you doing? Hey, look who's here. How you doing, buddy?
Great.
You finished with your assignment?
No, I was going upstairs to get my math book, but I did want to say hi to you.
Oh, cool. Say hi.
Hi.
Hi, everybody. All right, go get your math book, and we'll finish
Bye.
it. Okie dokie. Sorry, that was my son. One of many. There's 3 of them floating around here. Exponential function, what do we got? Our $100,000 is our starting. And 1 minus 0.03, that's the depreciation to the t. There's our equation. There's our amount of our house. Notice 1 minus, if I could put, if you want to use your calculator, you go 1 minus 0.03 is 0.97. 0.97 less than 1. That's how we know depreciation. Remember, we looked at the graph, and the graph is going down. Okay, so 10 years. Do we plug 10 into here, or do we plug 10 into there? Which one's years? These are years, so for 10 years, 100,000, 0.97, just did that on a calculator to the 10. Let's see what it does. 100,000, 10,000, 100,000 times 0.97 to the 10, and the house will be worth $73,742, and let's go 41 cents. You see, depreciation, things are getting smaller. They're depreciating. They're getting less and less every year. That's what depreciation. You buy a car depreciates in value. It doesn't go up in value. Stocks go up in value, hopefully. Half-life, when it'll be half? Well, we started with 100,000. So what's half? How much is half? Half 100,000 is 50,000. Okay, so here's the question. When will it be 50,000? Remember, that's the time. That's the money. So when will it be 50,000 is solving for t. So we put it in here. And like we said, our strategy is to graph these on the calculator. Okay, we got 50,000. Clear that old one. And the old one's 100,000 times 0.97 to the x. We use x always in the calculator. And check your window again. Remember, we're doing $100,000. Okay, and so 10 years, I'll do a little prediction. 10 years was 70, has not gone half yet, so I'm going to go maybe 25 years. Because 10 years was way too small. And I'm going from 0 to 100,000. Let's see. There is 50,000. Here comes 100,000. Oh, maybe more than... yeah, I'm going to go bigger. I'm going to go a little bigger. I'm going to go 50 years. Just so I could see a little better. Here it comes. There you go. So we could see the intersection right there. So second calc. Find the intersection. Enter, enter, enter. And it looks like 22. T was 22.75. Okay, what does that mean? This is the key. This is the key to the problem here. Interpret what that means. Okay? Your house will be half the price you purchased. Hey, you're back. Okay, get your...
No, I want to... I saw Danny and Matthew playing, so I'm playing with them for a little bit.
Okay, and then when I'm done here, we'll finish our work. Okay.
Can we do that?
Sounds good.
Okay.
Their house will be $50,000 in, now what year? Don't say 22 year. There's no such thing as 20. The zero, you got to know the zero. Zero was 2005. So if we add 22 to that, 2027. Your house will be half the price you paid for it in 2027. See how that works? Remember, think about the two different types of problems here that are going to be on the test. This was growth, 1 plus, and this was depreciation or decay, 1 minus. That's the only difference. Everything else is the same. Okay? Here, let's do a couple more examples. Price in dollars after X months in the market is this. Oh, what is that? That's linear. Remember, you got to be able to tell the difference. There's linear. Okay, what's 100? Well, there's only two possibilities, the slope or the y-intercept for lines. 100 is the slope or the y-intercept, and so that is the starting amount. That's the starting amount. The price. How much did it start at? It started at 100. The y-intercept when time is 0. What's plus 2? Okay, what does 2 mean? It's positive, so it's going up. So in our case, the units are price, dollars here, dollars, and months. And remember, it's change in y. Change in y. Use a little triangle. Change in y over change in x. So y is dollars. The function is dollars. X is months. So it goes, so the price goes up since it's positive, up $2. Now you got to get the units right. The price is dollars, that's the Y, and X is months, X is usually time, $2 per year. Price goes up $2 per year. You see what I mean? See how that was? Whereas, let's look at this one. This is X is in the exponent. Now, I saw some people's papers. Don't write 5 times 2X. Remember, make the X look like it's in the exponent for exponential. That's not correct. Make it look like it's up there. Okay, so this is exponential. Let's write exponent. Okay, so describe 5. 5 is still the y-intercept. So 5 is still the price. 5 is still the y-intercept. Remember, y-intercept is first on this one. So that's still the starting amount. Okay, then what does 2 mean? Okay, 2 is the multiple. We don't call it slope. Okay, 2 is the multiple change. Okay, 2 is the growth. Since it's bigger than 1, 2 is the growth per month. So the growth per month. Now remember, when we say growth or decay, that's multiplying. Whereas slope, it's adding. Okay, use your calculator for trial and error. Use trial and error here. Use your calculator to find the product when they'll be the same. Okay, I like when as soon as they say same, when will 100 plus 2x equal 5 to the x? When will they be the same? Well, I think it's easiest on the calculator like we we're just doing. Let's clear out these. We want to see when they're going to be the same. So we'll do 100 plus 2x for the first equation. Second equation, we'll do 5 times 2 to the x. And let's just zoom. I have no idea, so we'll zoom decimal, and let's see what happens. Here, oh, it was 100. It was 100, so I'm not going to see it. All right, so I think we got to do this a little bigger since the y-intercept was 100. So I'm going to go for, I don't know, 0 to 10. And let's go from 0. The y-intercept was 100, so I'll go 150. Let's see what happens. Ooh, wait, did I type something wrong? Check my window again. 0 to 10. Oh, yeah. 1 is that. 0 to 150. All right, there's one line. Here comes the, look at how it looks exponential. Ah, look at that, right in the middle. Second calc, intersect, enter, enter, enter. Remember, we have the TI calculators online, so you could use that. So it looks like when x is 4.4 and the y value is 108.8. And of course, what else could we have done? We could have made a table and just started a table. Plug in 1, 102, plug in 2, 104. And then here, we could just start typing in 1, so 10, 20. Just start typing it in there and see when they cross. Nothing wrong with that either. I found the exact number. If you have a quantity that grows exponentially, what will happen to the output value if the input value increased by 1? Okay, so what happens to the output when we go up by 1? Okay, well, this multiple is 10. Okay, so when the output goes up by 1, so when x goes up by 1, y goes up by 10. You see that? Because the multiple is 10. Okay, so now when x goes up by 2, here comes the point. X goes up by 2. The y doesn't go up by 20. That would be linear. It goes up by 10 and 10 again. Now, what are we supposed to do with exponents? If you're thinking linear, you're going to say it went up by 10 and 10 again. That's 20. That's linear. You're adding. Exponentials, we multiply. So if it goes up by 10 and then 10 again, remember we have to multiply those. So the y goes up by 100. That's the point of the problem. Linear versus exponential. That's what this whole sheet is talking about. Linear, if this was linear, when x goes up by 1, y goes up by 10. Great. When x goes up by 2, y goes up by 20. When x goes up by 50, y goes up by however many that is, 50, 10 plus 10 plus 10 plus 10 plus 10 plus 10 plus 10, 50 times. Whereas exponential, when x goes up by 1, y goes up by 10, same rule. When x goes up by 2, y goes up by 10 and 10 again, but that's multiply. Okay? So, you see that? Does that make sense? That's this whole sheet. All right, one more. Let's do one more example, and then we'll call it a day. Let's see how, looking at a graph, just a regular graph of this. All right, use this graph. Now let's see the points that we got on here. The first point is 0, it's kind of hard to see, 0, 3. 0, 3 right there. I'll put 3 in there. And the next one is 1, 6, it looks like. 1, 6. It looks better online here. Let me pull it up online just to double check. Yeah, 1, 6. All right, so how did this change? Now, looking at the graph, it's not linear, exponential. So the change, let me change colors here. That's how you look first. This is change, and you got to think add, subtract, multiply, divide. This is change by 2, times 2. There's our rule. Our rule is times 2. So we're just going to keep timesing 2. Going this way, times 2, 12. Times 2, 24. Times 2, 48. You see that? Whereas if we go backwards, divide by 2. Divide by 2. Ooh, 3 halves, 1.5, whatever that is. Divide by 2 again, 3/4, or if you use your calculator, 0.75. You see, because one way, this is going this way, times 2, times 2, times 2, not adding. That's linear. Divide by 2. Divide by 2. You see? That's the point of this graph. What's the equation? You should be able to figure that out by now. What's the y? Remember the formula is y equals ab to the x. A is your y-intercept, so 3. And b was our growth. So b was the times 2. And don't forget to put to the x right there. See, I say times 2 to the x. You see that? Let's look for comments. Just say a comment if you're stuck on something. Or if you're watching this later, send me a message. Is this a function? Sure. Remember, we had the horizontal line test, not the vertical line test. We had the horizontal line test. Yes, because it passes the horizontal line test. Remember the horizontal line. Oh, I'm sorry, with functions. I'm sorry, I'm working the wrong thing here. Sorry. This passed the vertical line test. Functions is vertical line test. I thought I was talking about inverses. Because let's review inverses here. Inverses, what's the rule in inverses? The x's and y's switch. Okay, x's and y's switch. Use the table for f to find the inverse. So at 0.75, we get -2. You see, I switched the x's and y's. At 1.5, we get -1. At 3, we get 0. You see what I mean? How the x and y switch. I could even go like here, -2, -1, 0, 1, 2, 3, 4. I could just copy all the x's down to get the points. And then here on the x's, they go for the y's right there. So I go 3, 6, 12, 24, 48. See what I mean? All right, now be careful. Are you looking at the function or are you looking at the inverse? That's where people are going to make mistakes here. They got to focus on function or inverse. When the function's 1, here's the function. This is f. This is f inverse. When the function's 1, I get 6. When the inverse is 3, I get 0. Okay, not 24. This is the inverse. I'm looking at the inverse there. Okay, when the function is 2, just read the chart, I get 12. When the inverse is 6, I get 1. You see that? For what value of the function gets you 3? We're looking at the function. What value of the function gets you 3 is 0. Remember, that's what value of the function gets you 12? 2. You see, what value of the function gets you 12? So remember, think about this. Is x is in the parenthesis, y is not in the parenthesis. So this says when y is 3, what's x? Of the function. So it says, look here first. When y is 3, what's x? Look, same thing with the function. Look at the function. When y is 2, what's x? When y is 2, x is 12. You see, same idea. We're just looking at the inverse function. So pay attention to which, this is why we do function notation. It tells you which function to look at. When y is -1, what's x? 1.5. Remember how we had g of x and f of x and all those functions floating around together? The letter told us which function to look at. Well, that's the same thing right here. This is just telling us which function to look at first, and then the x is the one in parentheses, the y is the one not in parentheses. So the question could ask both things. That's a great review of what's going to be on the test. Okay? All right, so looking at the test next week, there's more worksheets posted, more review sheets posted, and then we'll test next week, and we'll go over those, and we should be okay. So finish all these worksheets. Each day there's just one front and back, 2 pages. Each day is 2 pages of worksheets. That shouldn't be too bad. And then after that, we're going to be reviewing for the Harper final, and you have to take the Harper final because that's 15% of your grade. Okay? All right, everybody have a good day, and send me an email. Send Mr. Byrne an email if you're stuck on something. Anything you need. Have a good day, everybody.